Okay, our goal is to finish up, and if you looked on the syllabus says that we have chapter 48 left and one section from chapter 49. And that one section from chapter 49 I actually pulled into this portion of 48, so that it's just 48, and we're just.
Look how much space I have. One more day. You're efficient.
Did we fill a whole notebook?
And some. And I have some back.
Oh man, you're welcome for that.
How convenient is that?
That is convenient. Is what? Chapter 45? Oh, that's okay. Chapter 45 was short. We sure are. Okay. Chapter 48. The title of chapter 48 is Neurons. Neurons. And there are a lot of things we need to talk about in this chapter. We need to talk about neurons and how they are unique among animal cells. We need to talk about the nervous system and how it is unique among animal organ systems. And I guess that's really it. Okay. Many times during this class, we've talked about communication. And I need somebody to remind me of the definition of communication. Emma.
Transmission and reception of signals.
Yes, the transmission and reception of signals. And many times in this class, we've talked about specific forms of communication. We've been talking about chemical communication. And somebody remind me the organ system that plays the largest role in chemical communication. Rick.
Oh, chemical.
Yeah, in chemical. Katie? Emma? The kidney is involved.
He said organs. Oh. Lungs. Wait, no.
Oh my lord.
Katie? No.
No, because that's electrical. That's what I was
So, the organ system that plays the largest role in chemical communication is the endocrine system, right? Endocrine system, endocrine signaling. Now, neurons and the nervous system plays the dominant role in our other main type of communication, which is Trinity. Rick, electrical communication. The transmission and reception of now electrical signals. Okay? And just to put some of this in context, your brains, being that, your brains won't be fully developed until you're in your mid-20s, but your brains are pretty close to fully developed. You have approximately 100 billion neurons in your brain. That's a big number. That's a lot of cells, and then on top of that, you have other cells as well, and every single neuron is involved in electrical communication with other neurons and with other tissues in your body, okay? Just to kind of put this into context. All right. Now, just some basics, okay? Tori, be kind.
Yes, okay.
You know, the beauty of kindness is it's not recipient dependent, right? So your acts of kindness do not require anything in return. You know?
No, you don't sneeze and she'll tell you to shut up.
Me?
What? Tori,
What?
we're not talking about this.
I'm just saying, like.
Okay.
So rude. Shh. Both of y'all.
Nervous systems. Please write this down. Nervous systems.
Why did you be like that?
Why is what?
Your knee.
I don't know.
What? It's just a V.
It's like a
Yeah, but it kind of,
elongated.
yeah, I don't know. It felt right. Made of neurons and what we call glial cells. So the nervous system is made up of neurons, these cells that are involved in sending and receiving electrical signals, and made up of glial cells, which are supportive cells. Another thing about nervous system, and again, this is just kind of big picture, nervous systems are unique to animals. And I'm going to put this here. And so these are unique to animals' nervous systems, and all animals have nervous systems except sponges.
Not the water.
Yes, you're talking about the ones you can use to wash dishes?
No.
Yeah, if you get living sponge, absolutely. They work great. You can walk along the Mediterranean Sea on the coastline and find yourself all sorts of living sponges and take them home and use them. They're way better than synthetic
Can
sponges.
you actually use them?
Yeah, you can use them as a loofah or you can use them to wash dishes, and they're way, way better than synthetic sponges.
They move?
Mark and then Kyle. No,
They move like
no, once they dry out, they die.
Okay, so like answer
Mark's asking a question and I can't hear him.
so like coral would also have a nervous system.
Yes, coral do have nervous systems. You bet. Now they're simpler than our nervous system, but they do have nervous systems. Kyle, you had a question?
What's a glial cell?
Glial. It's a supportive cell.
wild though.
Let's do this. Supportive cell. It's the kind of cell you lay your head on their shoulder and they tell you everything's going to be okay. It's the kind of cell I aspire to be so that I don't have people tell me that they know that I have no concern for their emotional well-being. Do you want me to just hand you some more pencils in case those just keep go flying? Now, while all animals except sponges have nervous systems, not all nervous systems are created equal. Okay, so this is a small portion of chapter 49 that we're going to pull into here. And so I'm going to show you some images. May I erase this? Yes. So I'm going to show you some images and point out some important concepts.
No, you can't erase the I'm not done. I'm not done.
But you've got the top. The top is done?
Yeah.
I know it's hard to write things, but you're not even writing. You are done. Oh, I was gonna say it makes sense that you couldn't finish because you couldn't hold on to your pencil. But
Like, have you ever heard the story of the boy who cried wolf?
have I heard the story of the boy who cried wolf? I've lived that story.
Next time
He was the boy.
Next time she says that don't erase it, and when the time is real, you'll think that she's just trying to trick you.
She said that, and I just laughed at her saying it, so I repeated it.
That I'm the wolf?
Yeah.
Okay.
But then I can
So Mark asked a really good question. Most of you missed it because I got you to just be quiet enough that I could hear his question. But he asked the question, do even coral have nervous systems?
And then you answered. You answered. You said yes, they do.
Oh, well here's a hydra, which is in the same phylum as coral. And when you look at an individual hydra, the difference between a hydra and a coral is that coral are colonial, hydra are solitary, but structurally they're very similar. And so the nervous system in hydra or in coral consists of what we call a nerve net. And so it's basically you get a signal here, some kind of a stimulus. So you get a stimulus here, like you poke that hydra, which will work. We'll work a little bit with some of these animals after the AP exam. You'll enjoy this.
Really?
So you get a stimulus here, the signal goes in all directions.
Are you gonna bring us to like sea cucumbers and sea anemones and corals and sea sponges?
Stung?
Yes.
You say a jellyfish?
Next question.
See enemy.
Okay. There are two options for what you could do with this slide. You can draw what you see and write what you see, or you can summarize this and say the simplest of animal nervous systems is the nerve net, and any kind of a stimulus results in signals moving in all directions. You see that? You get a stimulus here, the signal moves in all directions, and there's no central processing center.
Wait, so the simplest
Nervous system.
Yep, is the nerve net. What's that?
Why though?
Why?
Yeah.
There's no central processing center, there's no direction, there's no directionality to the signals. You get a stimulus, signals go in every single direction. Okay? And so you could write that, or you could just draw what you see. You can draw that hydra with its nerve net, and then, you know, write down what you see. Here is the next simplest nervous system. So not the most simple, but the next simplest. Okay, we find these in animals that are in our phylum Echinodermata. And so one of those are sea stars, but other organisms in there, urchins, are in there. Somebody said sea cucumbers. Who said, are you going to bring sea cucumbers?
I said, are you gonna
Yeah.
Well, I don't know.
Well, anyways, those are in this group as well. And so here, there's directional movement. Directional movement of signals. So you don't have stimulus and then signal goes in all directions. You basically have like stimulus, and then your signals move and radiate down the arms. So you have directional movement of signals, but still no central processing center. You see that?
Is this one called
nerve ring or
what
the
is this
radial
called?
nerve?
Yeah.
You can call it a nerve ring or just a simple nervous system. And so you don't just have signals moving in all directions, you do have some directional movement of signals, but there's still no central processing center. So there's no, I don't know, really good coordination of a response.
Wait, so it's the central nerve ring because it makes this, like the directions move, so why is it different?
Then this?
First one
One of
is
them is
everywhere.
go
The other one
So-
is direction.
Yep. So when here, if you get a stimulus anywhere, that signal radiates through the entire organism. Here, if you had a stimulus, so I drew it here at the central ring. If you had a stimulus here, your response to it would only be in this arm. Okay? Your response to it's only going to be in that arm. Okay. Questions? Don't erase it yet. How about now?
No.
That's not very good.
Oh, those are delicious. How about now?
Yes.
Okay. And so here we can get some more sophisticated nervous systems. And so now you've got a centralized processing center.
Josh, we're gonna get a gecko in here. Oh, can we go?
Central processing center. Can we get a gecko?
Can we go like gecko?
Oh my gosh.
Oh,
I have your question.
Do you know what you need in order to legally obtain wild lizards.
Some kind of license.
A fishing license.
Really?
And that's it. So a fishing license will allow you to legally obtain fish, amphibians, and reptiles. So if you have a fishing license, you can catch lizards and snakes
Why would
as
you
long
wanna
as they're
catch
not
snakes?
protected.
Why would you want to fish?
Tori.
So, you know how like when lizards' tails fall off, they like grow back?
Yeah,
And when like starfish's feet get cut off,
Yeah.
they, like,
they grow back.
do they have a similar, like, are they made similarly? Like, do they have the same type of things inside of them that can do that? Or is it just kind of
I mean, yeah, yes. Now their nervous systems are completely different, but the ability to regenerate lost parts, yeah, I mean that process to basically you have to re-engage development. So when you lose a structure, you've got to develop it again, and so you've got to re-engage that.
So why don't other like animals have that ability to?
That's a good question. It's a good question, and the answer to that is it's complicated. Yeah, it's complicated. It's energetically costly to regrow new parts, and so there's an advantage to not doing it if you don't regularly lose parts. So lizards have to regularly regrow their tails because they can actually detach their tails to escape from predation. So. They also need their tails a lot more than like a small mammal would because they use their tails for balance a lot more and then also for heat exchange. What's that?
Except for their head.
What's that?
They regrow all parts.
So lizards can very easily regrow digits and sometimes their feet, but an entire limb.
Like their arms.
It depends. Yeah, it depends. They won't always regrow back. The tail will, digits will, the hands usually will, but an entire arm might not. Because again, it's a very expensive and costly process. Emma.
So is the first one just called mollusks?
A mollusk?
Like what category would that?
Well, so yeah, the phylum is Mollusca.
Like for your nose, 'cause the other one was mirroring, so what just like that one?
Oh, complex. Yeah, that's a good question. So both of these fall under a complex nervous system. You would call both of
The
these.
other ones are simple nervous systems.
Yep, the other two were both examples of simple nervous systems. These are both complex nervous systems.
So they have a
Processing
central
center.
process.
They do. They have a central processing center. And you'll see in just a moment, we'll focus in on complex nervous systems. You have a very strict movement of materials. Okay? Yeah.
Like it's a public so
Okay.
about the squid, how do people like eat squid like lively?
How do you eat them?
Like lively, like you don't cook it.
Oh, I mean, it's because it's very unlikely that they're going to have parasites or bacteria that are going to cause any kind of pathology for you.
But is that like possible if the arm of the squid will like kind of attach it or like?
Oh, sure, but that, I mean, you just swallow it whole and it doesn't really get a chance to do anything. All right. Okay. So, in vertebrates,
Are we back in chapter?
we're still in chapter 8. I mean, yes. This is 48 and a little bit of material coming in from 49. So,
We're like
Yeah.
merging it.
okay. Invertebrates and complex mollusks like squid.
Is this a new point or continuing from the past? Like the complex?
It's a new point because we're gonna actually focus in on complex nervous systems
Invertebrates.
and invertebrates and complex mollusks we have complex nervous systems. And in complex nervous systems, you have very specific structure.
Oh, so the vertebrates make sense. It's like the spinal cord, right? Pretty much.
Yeah.
I can school.
Yep. So complex mollusks like squid, octopi, cuttlefish, the nautilus.
I'm just a little.
Will you bring us a cuttlefish?
No.
He needs to get his fishing.
I might bring us like some calamari to eat.
Yes, yes.
Wow.
Okay. And so what I'm going to do is I'm going to show you the hallmark of a complex nervous system from the point at which a stimulus is received to where it's processed and then some response is executed.
Is that under this point? Or
Yes. So here's here, and this is under this point. Okay,
I like your variation of points.
thank you. So step one.
It's cute how you this.
Yeah. What's okay? Step one. Sensory tissues receive. Where? Thank you. Receive a stimulus. Okay, so step number one, some sensory tissues receive a stimulus. These tissues might be tissues inside of your nose that will receive a chemical stimulus. They might be your retina at the back of your eyes that will receive a light stimulus. They might be cells at the base of a hair follicle that will receive a tactile stimulus. Okay, so that's step one. What is step one?
Sense the stimulus.
Thank you. Wow. That sounded a lot like when we were greeting Mr. Brown, where you have different rates. Step two, sensory neurons. Carry electrical signal to a central processing center. Now, sometimes that's going to be the brain. It's not always going to be the brain. If it doesn't need a really complex response, it might not always go all the way to the brain. Okay? So step two, sensory neurons carry electrical signal to the central processing center. And again, that central processing center, it might be your brain, but if you don't need like a really complex response, it might not be. Like for instance, if you touch something hot, you're going to pull away from it, and that signal will never really go to your brain. I mean, eventually it'll go to your brain and you'll be like, ow. But long before that, you'll pull away from the heat. Yeah, toward it.
So some people who like don't have the sensory like stimulus built out, that like, when they like touch something, they like, don't process to pull it away.
Yeah.
Is that like just you like your brain being underdeveloped, or is it you missing like certain sensory tissue?
There's a lot. There are a lot of ways in which this can go wrong. Yeah, there are a lot of ways in which this can go wrong. Lydia.
Aren't there like some people, like I'm watching this video about this girl who like she can't feel anything, so she can literally
Yeah.
oh I've seen this before. Like scratch herself or like touch like a hot stove and she wouldn't feel it.
Yep. There's a genetic illness that results in the inability to detect pain, and it's a neurodegenerative disease. So you're incapable of sensing pain.
Yeah, that's like terrible.
Yeah.
Or like emotional.
And so, you can sense emotional pain, but there's another illness, which some of you may think that I have the inability to sense emotional pain, and that's called psychosis.
Does that make you a psychopath?
It does.
And the other one?
Or a
She doesn't
sociopath.
want to feel anything.
Yeah. Go on.
Okay, two questions. One, I forgot the first one. What's the difference between a psychopath and a sociopath?
It's a subtle difference, and I don't exactly know. A lot of times the two terms are used interchangeably.
Psychopaths, like, they can't feel any emotions like guilt or empathy. Sociopaths basically only feel it if they hurt someone they.
Oh, that there's like a degree of
So
detachment.
it's better to be a sociopath. Wait, so sociopaths only feel like hurt someone they love? Or just
Pretty
need
much. They can feel remorse and guilt. A sociopath can't do that. And there's like a few more differences.
Oh, psychopaths feel remorse.
Psychopaths cannot.
No, they can't feel anything. Yeah.
Psychopaths are more manipulative.
Okay.
How does that happen? Like, how does that, like, do you, like, become a psych, or are you, like...
You can be born that. You can be born with an inability to feel emotion, or most of the time it's the result of trauma.
Like physical trauma or, like, mental trauma?
Either. Both.
That's interesting.
Yeah. Okay.
Now we don't know.
Any questions here? Before we get really deep and off into a conversation that we can have but we shouldn't, we need to do step 3.
Do mollusks have sensory tissues?
Oh, they do. Yep, invertebrates and mollusks, you've got complex nervous systems. You bet. Okay. Shh, guys. Be quiet. Tori, be quiet. Trinity, be quiet. Emma, be quiet. Step 3. Your central processing center. Your central processing center integrates information and determines a response. Okay, so step number 3 is that our central processing center integrates the information, that electrical signal being carried on sensory neurons, and determines a response. What is the proper response to this stimulus? Step 4.
Was that right?
Not a lot has happened in the time you've been gone, Katie. Step number 4. Motor neurons carry. Did you think I was talking to you?
She said what, didn't she?
I don't know. I didn't hear her response. I just heard the laugh in response to her response.
I wasn't watching what you were writing, so I was like, kind of just,
Yes.
yeah.
Motor neurons carry electrical signal to what we call effectors. Okay, so step 3 was that the central processing center integrates this information and determines what the response should be. Motor neurons carry the electrical signals from the central processing center to effectors. That's an excellent question. We'll talk about effectors in the very next
So
point.
it's like cause and effect.
Yes.
So what, neurons are like Uber and neurons are like Lyft?
No.
They like carry, like, it works, it's us.
No, they take it to the effector, the effector's the thing
They're
that
literally the
does
same
something.
thing with different names.
Shh.
When Kyle thinks he's being funny.
Okay. Step 5. Effectors. And then in parentheses, we'll say what these are. These are usually either muscles or glands. Effectors, either muscles or glands, carry out the response.
That's really well named.
So, what's really well named?
Effectors.
Oh, effectors? Yeah, thanks. Came up with it myself. So if you touch something hot, you pull away from it. Basically, when you touch something hot, the sensory cells in your fingers, it absorbed a really high temperature. Sensory neurons carried that to a central processing center in your spinal cord, and then that sent a signal back, pull away from it, and it happens very quickly. And then it also gets, I mean, eventually it'll get to your brain, but after you pull away from it, and then you'll be like, wow, that was really dumb. You ever touch something hot that you knew was hot, but you touched it anyways?
Yeah, I just. Oh yeah, I do.
But it that with
Yeah.
Do you want to see how hot it is?
Yeah. Well, sometimes it's
I
because,
thought it was like let's just touch the side.
well, sometimes it's because somebody tells you not to touch it, which means you have to touch it, right?
Yeah, that's true.
It's like when I tell you to stop talking, you're like, now I feel compelled to talk. I didn't even want to talk before. I wasn't talking, I was totally quiet. And then Dr. Eagle shushed me, and now I'm like, oh, I'll show him. Try to shush me.
That's the whole like you won't mentality.
That's, okay, shh. So I'm going to share something with you that I probably shouldn't because it's being recorded. And, you know, it's personal anyways. But anyways, my two daughters. So our oldest child and our youngest child, the reason why they were born where they went when they were is because somebody told me I should wait. My wife's grandfather said, you guys should be married for 10 years before you have your first kid. And I said, bet me! And I thought it was born, yeah, 10 years. I was like, that's absurd. I was like, 10 years? Well, we've been married for 10 years this year, so it would be like right now. And then so our daughter was born 10 months later. I'll show you. And then after our son was born, my mother-in-law was like, you guys should not have a third child. Because when you have a third child, it changes the dynamics. Our third daughter was born 10 months later. It's just, you can't tell me what to do.
She's like, nah. Do
Okay.
not give me 100 in this class.
What's that?
Don't give me 100 in this
Not
class.
give me a 100.
I don't give out grades, you earn grades.
Do not make me earn
I don't do anything but equip you. Your grade is determined by you, not by me. Okay. Alright? So do we have our 5 steps?
Yes.
Okay, cool. No, nobody needs. All right, cool, sweet.
Really? Say I won't.
Now, if you want to tell me don't get a 5 on the AP exam, I'll go do it. I'll pay to take the AP exam and sit and take it.
Don't give me a
Talk about wanting to do this. No one has to tell you that you won't.
You should
because
take
we
I don't know if they'll let
know
me. I don't know if they would let me take it, but I would love to take it.
You could just be like, hi, I'm taking ice cream. And then take it.
So you need your GED.
He needs a GED, he has a PhD.
Oh, I did a V like that again. Maybe it's just how I do my
That's the
V's.
regular V.
It's
No, the right side is too
Oh, yeah.
long.
It kind of looks like a letter.
It looks like what's that Greek letter? Oh no, the Greek letter is this way. The new? Is that a new?
That's
No, you just write a V for ours.
But it, yeah. Anyways, the central nervous system. Central nervous system is composed of the brain and spinal cord. And the central nervous system, this is our central processing center. Now, not all of these stimuli require the brain to get involved in determining the response. Like again, that reflex. So we have reflexes and the brain does not get involved in those responses. Another reflex is when you start to lose your balance, to shift the way you're standing, your brain's not involved in that either. Yeah, Emma.
Why is it harder to keep your balance when you close your eyes?
Oh, but like your ears, it's not like.
So when you close your eyes, your other senses are elevated in terms of how much you're thinking about them, and so you overreact to the feeling of imbalance, where you normally wouldn't overreact to that, but when your eyes are closed, those senses heighten, and so you overreact to kind of a feeling of imbalance. Yeah.
Have you ever tried balancing like on your because with your eyes closed? It's so hard. What she asked? You ever tried balancing on your what? I feel like I'm like on your cheeky.
I mean,
Why do you do that?
you know, you're talking.
Stop asking.
You're talking to me that on first sight you would expect that I don't have great balance, but I what's the term I'm looking for? I'm a nimble big man. Yeah, I am a nimble
You jumped that
big man.
subject.
Oh yeah, I cleared that planet, no problem. I mean that dude's mouth fell open. I knew exactly what he was thinking too. He was probably thinking, man, I hope he doesn't ask me to jump over this planet because I don't know if I could do it.
I want to be him one day.
Oh man, we should have gone ice skating for my teacher feature
No.
No.
instead of bowling. Mingle on ice. That sounds like that would have been a great name for a teacher feature. Just mingle on ice. Oh man. So the peripheral nervous system.
Next year, next.
Sensory structures, sensory neurons, and motor neurons. Notice what is not included in the peripheral nervous system are the effectors. The effectors are not part of the peripheral nervous system, even though the sensory structures are. Sensory neurons and motor neurons, these are part of the peripheral nervous system. The effectors are not part of the peripheral nervous system. Okay? All right? Any questions about this? These are complex nervous systems. Your 5 steps, and then these 2 divisions. You love it, right?
I keep putting the U and the E in the wrong.
Oh, the U and the E in the wrong spot?
Yes. Because it sounds right to me.
Well, because neutral is N-U-E, right? Is neutral spelled N-U-E-T-R-A-L?
Neutral?
Or is it N-E-U?
Wait, what is it? How do you?
And then what about,
Oh, I can like it's not.
I don't know. Maybe I'm spelling it wrong.
No, you're definitely spelling it right.
Okay, thanks.
Actually, I don't know.
Here, I'll check.
Carlos.
Yeah, I'm spelling it right.
I feel like
It's probably just like
your brain will work on this.
Okay? Shh. May I erase this, please?
No.
No?
I can erase it.
I can? Thanks, Scott.
Make sure it's on.
Wait, like,
All right.
I can do 2.
Yes, that's the point.
So, other than pulling away from a hot temperature, what are some other reflexes? Reflexes are things that you don't need to think about, they just happen. Mark.
It's that classic doctor one where they.
Yeah, the knee-jerk reaction, right? Where they hit that nerve right underneath your patella.
I've done it with my pencil before.
Yeah, I'm pretty good at it. If you want to test your knee-jerk reaction, I'm pretty good at hitting that nerve. But anyways, that's another story for another time. Okay, so the knee-jerk reaction, that's a good one. Any other ideas?
When your nose gets hit and you start crying.
When your nose gets hit and you start crying? That's a big, but that is a big one, right? When you hit your nose and that tear response, that is a big one. Yawning is a reflex that you don't need to think about. Sneezing, especially with high amounts of light. Breathing is a little bit different.
What do you think about sneezing at the outside?
Yeah, do you know that? Shh. Have you ever noticed that little kids, when they go out into the sun, they sneeze?
Did they?
Yeah, I'll tell you why. So the nerves that run from your nose to your brain are very close when you're little to the optic nerve that runs from the back of your eyes to your brain. And so when you're little, a lot of times your brain gets confused when you see bright light. that it gets confused that there's something in your nose, and so it issues a sneeze response. Yeah. Now, usually as you get older, those two nerves separate enough that your brain no longer gets confused, but some people keep that reflex throughout their life. Yeah. Where bright light will always issue a sneeze response. Okay. Shh. Look, everyone. Look, everyone. It's Mark's reflex, right? You brought it up. I assume you have this reflex. And so here's you're hitting this tendon right underneath the patella, your patellar tendon, and it excites that nerve. Shh. So the sensory tissue is the nerve inside of this tendon, and then here we have these sensory neurons carrying that signal to the central processing center in our spinal cord, and then the motor neurons carrying the signal back to your muscles in your leg to pull your leg away from that signal.
The hamstring extension.
The hamstring extension.
Quadricep contraction.
All right. It is currently 9:52.
9:52.
8:52. Whatever. 8:52. At 9:52, I'm long gone. So it is currently 8:52. We will take a break until 8:55.
Are you
Okay. Shh. So what I'd like for you to do with this slide is I would like for you to draw this neuron. You don't need to draw both, but I need you to draw this neuron.
The neuron is those big circle things.
This entire cell right here is the neuron. Okay? And so I need you to draw this neuron, and I want you to label this, and this, and this, and I want you to label this, instead of calling it the myelin sheath, I want you to write this. Glial cell. So draw that neuron really quickly, and I'd like for you to label the dendrites, the cell body, the nucleus, and point to there and write glial cell rather than writing the myelin sheath. Something else I would like for you to do is put another arrow here where the cell body is and write this, organelles, so that you will see that and you will think all of the organelles that cells typically have, mitochondria, Golgi apparati, endoplasmic reticula, lysosomes, ribosomes, you're going to know that they're going to be focused in this cell body.
You must say dendrite.
Dendrites. Yeah, I guess that blue is right in the way, isn't
Accurate
it?
that drawing. Just
There, is that easier to see now?
Yes.
Dendrites.
Where the cell body? Oh, that's the thing in the center.
Yep, the big bulky part of a neuron.
Is that?
so the whole thing
I
is
can't really see what's in the center of this yellow thing.
The what you call the axon, this long extension. Oh, you should label this too. That long, skinny projection of the cell is covered by glial cells.
What?
You see, so here we have the cell body, right? You see the label? Here's the cell body. Here's the axon, this long, skinny projection off of the cell body, and that axon is covered by these glial cells. You see it? There's a glial cell, 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 so on and so forth, all the way down that axon.
oh, so the
that
axon
organelle
is like the
pointing at?
whole thing.
Yes, remember I told you that glial cells, they're the supportive cells.
Wait, hold up.
They're protecting the
So
axon of
the
the
glial
neuron.
cells are all just the little circles,
Yes, each individual,
and then the whole thing is the neuron.
correct.
Got it.
Yep.
What's the organelle pointing at?
The organelles, it's pointing inside of the cell body.
You can kind of see it.
Inside of the cell body.
You can kind of see the shadow next to nucleus, like a little green and a little red.
Yeah, it's actually technically pointing to a Golgi apparatus, but inside of there, here's the endoplasmic reticulum.
Are there different types of neurons?
There are. Yes, there are sensory neurons
Show you.
and motor neurons, and then there are the neurons that are part of the central processing center. Those are called interneurons. Yep. Okay. Do you like this? This is good stuff, right?
It's good if I don't have to draw it, 'cause then it looks. What is the axon?
The axon is a long projection of the cell.
Oh, do we need to write organelles to that?
But yeah, sorry.
Yeah, right organelles as well.
Where is it pointing
It's just pointing inside of the cell body.
to? Okay. That's not like.
Here, why don't you write this? Organelles in cell body. There we go. Okay, any other questions on this? Do y'all have this? Y'all drew this?
Yes.
Okay, one thing I'd like for you to write down here is this: electrical signals. Wow, electrical signals move down the axon. Shh. I'd like for you to write this: electrical signals move down the axon. Okay? That's why these axons are so long and they project away from the cell body. They are carrying an electrical signal down the axon to the next neuron, and then to the next neuron, and then to the next neuron, until finally the electrical signal would go from a neuron to what? In step number 4 and 5. Yeah, Mark.
To the effector.
To the effector. Okay, either a muscle cell or a gland. Alright? But ultimately these electrical signals will stay on neurons from all the way from the sensory tissue through a series of sensory neurons to interneurons in your central processing center to motor neurons all the way until they get to an effector and execute some response. Okay? So electrical signals move down the axon. That's why the axon is so long. It's, yeah.
So the nucleus is just the purple part.
Yes. Yep. All right. Any other questions about this drawing? Because now we need to talk about how an electrical signal actually works. Okay? It's a party. May I erase this?
Go for it.
No.
You should probably pay attention. Probably best for your educational information.
You just start making eyes the whole time.
I know exactly what he's talking about.
I'm kind of moving it up.
Okay. Shh. My coaster. Okay. How does an electrical signal work? I want you to write down that question, and this is what we need to address. How does an electrical signal actually work? We know how a chemical signal works. Yes?
Yes.
Somebody tell me basically the 3 steps in the process of what would we say? Responding to a chemical signal. Katie.
Bind the ligand.
Bind the ligand. Carrie. Transduce the signal. Transduce the signal. And step 3? Execute the response. Yeah, change in response to it. Okay? But how does an electrical signal work? How does an electrical signal work?
Zap change.
Just like that.
Okay. Every cell has an electric potential. Every cell has an electric potential. And those of you that took chemistry last year, which is all of you, somebody tell me what an electric potential is, or the units we measure electric potential in. Did you say volt? Not. Did you say bolt?
No, you said mole.
Mole? Oh, I thought you said volt. I was so excited. It is a volt.
That makes sense.
Every cell has an electric potential measured in volts.
Why does all the wrong answers rhyme with the right answer?
I don't know.
I said that you say a unipolars, yeah.
So every cell has an electric potential that we measure in volts. And here's why.
Need a bell.
I need a bell?
Yeah.
Do you think that would make people stop talking?
I feel like it would just make us laugh.
How about if I just got tired of it and just asked you to leave class? And then called your parents and
I
let
would
them
never
know.
talk to you.
Or called one of the deputies here in town and told them that they should probably follow you whenever they see you in public.
I don't know.
You're like, I don't go in public.
Nothing about deputy
It's fine.
I don't know.
Okay, so every cell has an electric potential. And here's why. I would like for you to draw this very beautiful cell. Do you see this cell?
Oh,
It's beautiful. Draw one just like it.
It's a circle.
How large
That's
should it be?
How large should it be?
Just wait till he does stuff.
All I'm going to do is to draw. I'm going to draw one structure on the cell, and I'm going to draw 3 ions. So however big is required for you to do that. I would say probably like this big, like the size of a quarter.
Mine's about the size of
So a dime?
no.
Okay. Every cell in your body has an electric potential because every cell in your body has what's called the sodium-potassium pump. Sodium-potassium pump. And this pump pushes things against their concentration gradient. And what type of movement moves something against its concentration gradient? Active transport. Okay, and so the sodium-potassium pump pumps out 3 sodium ions for every 2 potassium ions that it brings in. It pumps out 3 sodium ions, brings in 2 potassium ions. Okay? And so we are actively transporting sodium to where there's already a lot of sodium outside of the cell. We are transporting potassium to where there's already a lot of potassium inside the cell. And you're like, that's so cool, Dr. Engel.
That's so cool though.
Thank you. Active transport in the context of electrical signals. But something else is important about this. Not only are we actively transporting sodium and potassium ions, but what is something very important about this that you see?
There's 3.
It's like
3 positive charges leaving for every 2 that are coming in.
That doesn't seem right.
True or false? 3 is more than 2. That is true. And so what this is going to result in is what? If we are pumping out 3 positive charges for every 2 we're bringing in, what's
Eventually
going
you're
to
gonna have a
happen?
negative charge.
We're going to have a negative charge. Do you see these? These are negative charges. Do you see them?
No.
They're beautiful. Draw them just like that. Is even with this one, you see how this one's bigger than the rest? Draw it just like that.
Matter?
Yes. It matters very, very much. Yes, it does. No, it does. And you should have exactly 8 of them, and one of them should be bigger than the others.
And so it looks like it's a space thing.
Yes.
I I traded them in a string.
And you should have exactly 8 positive charges, and 1 should look a little bit like a cross.
Two of them do that.
They all look like crosses.
2 of them should look like a cross, and the others should look like something else, like an X tipped on its side.
Like a plus sign?
Should be exactly like this. Your understanding of this concept
7 or 8.
requires that you draw your cell just like this.
Yeah, I do.
I guess I will not understand.
Okay,
Look at that.
so now, we know that electric potential is measured in volts. And if I'm telling you that every cell has an electric potential because of this, somebody describe to me what electric potential is. Potential for what happens though? What happens during electrical movement?
The charging.
Movement of charges. Okay? So electric potential measured in volts is a potential for charges or for charged particles to move. Okay, it's a potential for charged particles to move. What's the voltage on a AA battery? No, it's not 12 volts. 12 volts is a car battery's electric potential. And you've got the 9-volt batteries. I think it's 2 point something. 2.7? 2.6?
I was close. 3.
I was close.
And so the electric potential, again, it's the potential for charged particles to move.
Price is right.
Shh.
Those who can't talk about it.
If every cell has electric potential because there's more negative charge inside of the cell and more positive charge outside of the cell, where are positive charges going to want to move? Into the cell, especially if they're what type of positive charge?
Potassium.
Not potassium, there's already a ton of potassium in there.
Then
What if there's sodium? Because sodium is positively charged, it's going to be attracted to the negative charge in here, right? Do you agree?
yeah.
Positive charge, negative charge, they like each other. Okay, opposites attract, right? Oh, see, that got y'all to like respond and smile. Gosh. You don't even know what I said. I'm gonna miss you so much. Is that?
Also see,
Just not Tori.
We won't miss
Just not
you.
Tori.
Yeah.
Teach physics.
Do you actually want me to continue to be your teacher, even though you believe that I have no concern for your
Yes.
emotional
Yes.
well-being?
Just Emma. Like, really
Emma.
Okay, so is the negative like in relative to what's outside, like the charge of
Well, it's not just relative; it's actually an overall negative charge. Our cells are negatively charged.
so it's not only the potassium that's causing it to be negatively charged.
Well, yeah, because the potassium is positively charged. So there's some positive charge inside of the cell, but there's way more negative charge than there is
So
positive
they-
charge.
they-
Well, so it's overall, it's negatively charged. Every cell in your body is overall negatively charged, and all of the fluid surrounding the cells in your body is positively charged. And so you have this separation of charge. You have this potential. Your body just creates a strong urge for charged materials to move, which is why we are great conductors of electricity, which is why you're encouraged to not go outside during a thunderstorm. Although we don't have many thunderstorms here, so you don't really need to worry so much about that. But if you live in a place in the world where there are a lot of thunderstorms, you have to start to think about this. Oklahoma, every day. Okay? Okay. So do you all agree that the sodium ions are going to be attracted to the overall negative charge inside of the cell? Yes? Because they are positively charged, they're going to be attracted to the overall negative environment inside of the cell. There's also very little sodium inside the cell. Why? Because it got pumped out against its concentration gradient. So not only does sodium want to move in there because it's negatively charged, sodium wants to move in there because there's very little sodium in there and there's a ton of it out here. Tori.
I was gonna ask, why are you not encouraging urge to go out in a thunderstorm?
Well, since like our bodies are small.
Well, but like,
So we don't
So we don't die.
but no, it doesn't make sense though. What is,
Then
why
this
does your
is
body react to it differently?
lightning.
Well, so you,
I
since
said thunder.
well, since your body's got electric potential, well, a thunderstorms are going to have lightning. So, and since your body's got electric potential, it encourages electrical particles to move, and some of those can be electrons during a thunderstorm. So you can end up absorbing a lot
You see it,
of
and then you
electrons.
wait, and then that's how far it is, because light travels
Okay.
faster than sound.
We okay with this? We okay with this? Okay. So I'm going to give you the four steps of an electric response. You ready? Okay, 4 steps of an electric response. Four steps of electric response.
Is this chapter gonna go on for much longer?
I have a 2.5 page,
No,
not
I'm
even
just
2.5,
wondering.
but
I'm just
like
wondering.
1 8.
I want to know if I should start a new page.
You know, the other night I was reading to my kids, and my son asked me how much longer I was going to read. Dad, how much longer are you going to read? He's like, can I go to sleep? I was like, sure, bud, go ahead and go to sleep. And he immediately fell asleep, and I was
Are you
like,
watching a book about cells?
Never watched
no,
I'm
it's,
reading.
no, I'm reading them the first Harry Potter book.
That's probably where it's going.
What was the difference between elastic
I'm
and
just
Nothing.
Oh, but why is there like
I don't know, because they can both be used as adjectives, so they can be used interchangeably. Electric, like you can't make electrical a noun, but you can make electric a noun. But then when they're used as adjectives, they're synonymous. Okay. Step 1. Cell is at resting potential negative 70 millivolts. Okay, so step 1 is the cell is at resting potential. You're like, Dr. Engel, how is that a step? Because the cell is it's maintaining resting potential. And why is it negative? Because the cell is negatively charged. And then we measure potential in volts, and then milli is a prefix that means what? 1/1000th of a volt. Okay? And so a cell, step 1, not, wow, this looks confusing because it's one cell, but this is step 1. Yeah. Step 1, cell is at resting potential. Step 2, sodium channels
I don't like those double backs.
open and sodium rushes in. So step 2, sodium channel, so you can't leave until 9:40. Hey, how did corporate time go?
It was great. Good.
Someone clapped.
No.
But y'all killed it?
we
Were you the best?
I did not.
we came together really
People
well.
didn't, people didn't show up. I forget who. There was a couple.
And there was, we were all blended, so it like wasn't like.
Yeah.
Really?
Yeah, anatomy was like everywhere.
Wow, that's unfortunate. Okay, so step number 2, the sodium channels open up and sodium rushes in. This step right here, I'm trying to remember. Oh, this step right here is called the depolarization. You know, I found out actually last week that I can ask people to leave class, and it was like,
I didn't know that.
yeah. Well, I taught at a
Mr. Klein
private
is at me every day.
I taught at a public high school for a while, and you were not allowed to make kids leave the class unless it was like an absolute necessity. Yeah, because if you kicked a kid out of class, they'd go roam campus and like graffiti all over the place.
Those baskets.
Mr. Klein is kicking me out of class.
They'd like do drugs, you know, right outside of the classroom. So while they were in the classroom, I could keep them from doing drugs. So.
I sat in the classroom in Mr. Klein's class like 15 years.
Junior high even though.
Like
Okay.
I used to argue for
So step 2, sodium channels open up, sodium rushes in. This is called depolarization. Step 3, potassium channels open and potassium rushes out.
Oh, potassium.
Potassium. So step 2, sodium channels open and sodium rushes in, depolarization. Step 3, potassium channels open, potassium rushes out. This is called repolarization. Yes, Emma.
Why do some of the element symbols not match the name?
Because they're names for the element in a different language.
What language?
Latin. It's always Latin.
No, with a lot of the chemicals, it's German. Some of them are Latin, but a lot of them are German. Because a lot of chemistry was done by German scientists.
Is that a word?
Yes.
It's chemistry, German word.
That's a good question. I don't know. Kindergarten is. Kindergarten.
I think
It's a German word.
Wait, so how do they translate the elements from? Is it just like obscure words? Like how do they translate from German?
Well, because we have a name for it in English.
Oh.
Yeah.
So it's, okay.
And then step 4.
because it's the element with how many. There you go.
Step number 4, the sodium potassium pump
How do you translate anything? Pen.
re-establishes resting potential. Wow.
Is that how you spell reestablish?
Yeah.
That's so
No.
weird.
That's definitely
That's
not
not
right.
how you spell it.
Ain't one.
It's like re-establishes.
That's that's totally how it.
There's one.
120.
How is it re-establishes? Then it's just
They're
reestablishes.
classically educated.
Oh wait, he's not right.
We also have like
Is re-establishes a word?
I don't know how to spell them.
No, but sometimes you don't know how to spell it. So my theory is you say it to Siri and then it'll spell it out.
You say sorry.
It's rest. Establishes.
Because it
Sorry. I said see.
I know. He's absurd. That is disgusting.
Also, you know, say cat.
Totally R-E-E-S, but this has it shown as 2 words, but
Wait, so how do you spell it?
Could we put a hyphen?
I think that you do put a hyphen.
No, they don't have.
well, here it has it as 1 word on thesaurus.com, reestablish, 1 word, R-E-E-S-T-A-B-L-I-S-H.
It's not a reliable source.
I'm taking a riot.
Okay, so
Right.
spell it
You know what?
on the
Now we know
thesaurus.
why Rick.
That's how it's spelled on the thesaurus.
Yeah, on thesaurus.com. Reestablish?
I'm tired. I can't feel my calves. I get this walking today.
No. Is it this? This is a legitimate word, right? Yeah. Spoken by a Latin teacher
What's the
herself.
real word?
Established.
Establish.
Root word of establish.
At this class.
Yes, stop.
Sorry.
Oh, yeah.
Okay. Any questions about these 4? Any questions about these 4?
No, sir.
Okay, you got these 4 steps of an electrical signal, Katie?
Does it have to be sodium then potassium?
Oh, yes. Oh, it is always sodium first and then potassium second.
Because you can't like make it extra polarized.
Correct. Yeah. All right. So I'm going to show you this in graphical form, and this is oftentimes how you would see this on the AP exam would not be like this. but instead would be in graphical form. So let me show you that. You ready? It's not a pie chart.
I'm waiting for the day.
Okay, this is disappearing. We won't use a pie chart in apbio. Because those are terrible data. The only people that use pie charts are marketing people that pretend they're scientists. Economists also use pie charts and they also pretend they're scientists. Like you can predict what's going to happen. Please.
Your crystal ball.
Relax. Relax. Draw this graph. Okay, draw this graph, please. On the x-axis, you are going to write time. On the y-axis, you are going to write membrane potential. Yes, ma'am.
Can we just wait till you finish? 'Cause I don't know how much stuff you
How many lines do you?
Just wait.
Oh, wait, then I can.
On the note paper, how many lines down and across?
Okay. On the x-axis, you're only going to put a single measurement, and that is less than 1 millisecond. On the y-axis. Oh, never mind. Never mind. Sorry. 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 6 milliseconds. Okay. 6 milliseconds. Sorry, I got so excited.
Excited.
Yeah.
To inform us of this knowledge.
Negative 70 millivolts. 0 millivolts. 70 millivolts. Just like that.
What's the bottom of negative?
Negative 70.
Is that? Oh.
It's gonna go like. Oh, it's gonna be like upside down. It's gonna go up and it's gonna go down.
There's step 1, right?
It's gonna be like.
The cell is at resting potential. Step 2, we've got the depolarization when sodium ions rush into the cell.
And then back up.
What number on the y-axis is it?
70 millivolts, 0 millivolts,
No,
negative.
where's two?
Just in the middle?
Oh yeah, somewhere in the middle. Usually somewhere between like 30 and 40 millivolts.
And should it be
Positive.
slanted line or?
Slanted?
Yeah.
Well, yeah, because it takes time. It can't.
Look at the heart.
Step 3, the repolarization, where the potassium channels open up and potassium rushes out of the cell. And notice it actually gets even a little bit lower than minus 70. And if you want to know exactly at what point, it's usually somewhere around
Minus 90.
like minus 80, minus 90.
Yes, you were. I actually was.
And then step 4, the sodium potassium pump reestablishing resting potential. Okay? So here are your 4 steps in an electrical signal. Now, the thing about these electrical signals is they tend to create a chain reaction. Creates a chain reaction. So when this happens at one place on a cell, when it happens at one sodium channel, right? Because step 2 was basically a sodium channel opens, sodium rushes in. Yes? Do you remember that? So when it happens at one sodium channel, it moves down the axon one channel at a time. Wow, I left off the A. At a time. Okay, so when it happens at one sodium channel, it creates a chain reaction and it moves down the axon one channel at a time. And when it gets to the end of the axon, the end of one neuron, it triggers the next neuron to do the same thing. And so you can carry this electrical signal down nerves as it moves from one neuron to another. Okay? No? Now, step 3, we called it repolarization. Sometimes you'll see step 3 referred to as hyperpolarization. What does hyper mean? Extra or more, and that's because it will go down even below where its resting potential is, and then it'll call 4 repolarization, but I prefer to call 3 repolarization and 4 the reestablishment, because then we get to use a word that is awesome. 2 E's in a row. Okay? Any questions about this? Very different than a chemical signal, yes?
Absolutely.
And then so eventually the signal will get to an effector that will do this. That the signal will trigger an effector to have this rapid depolarization, the rapid repolarization, and when it does, that effector will do something. If it's a gland, it will dump its product out. Right? Like a skunk. You know when a skunk decides to spray you, now you know its nervous system, its brain told that gland to empty, and that gland empties all over you. Have you ever been sprayed by a skunk?
No.
No? It's
Have you?
That's a shame. No. No, but it was gonna bring a smile to me and warmth in my heart.
Do we even
If I
have
heard-
skunks here?
Yeah.
Yes, we do.
Yeah,
Do we have skunks?
not a ton, but yes, we do have skunks that live here.
Like skunks.
There's skunks in the neighborhood.
Yeah.
My dog got sprayed by one.
Yeah. It happens.
My mom got sprayed
Okay.
by skunks and
And if it's a muscle, that's the effector. When this electrical signal hits a muscle and it rapidly depolarizes, it gets that muscle to contract. Boom! And then you pull away from that hot surface. Okay? Any questions on this?
So sad.
No questions?
No, sir.
No thoughts?
Is that our whole curriculum?
No. Please.
It's not our whole curriculum. But you said this is the last one.
No,
It is.
One thing from wait for one.
No, we already did it for you. You said, like, this is the part that is chapter 49 that I'm integrating in. You're probably
Wait, which
talking.
one was it? What part was that?
That's the safest section.
Which part was chapter 49, the very beginning? Like when we were talking about nervous systems and different animals? Okay. No more questions on this. We have... We have two more concepts that we need to learn, and then we'll be done.
Cool. Omar, so that's like we're done. Like,
And then we're done. Yep, we are done.
are you scared, Dr. Angle?
Yes.
Am I scared?
Yeah.
Of what?
It's like, it's a big moment, you know? It's your first class of training. It's like your last information.
Your last information.
Yeah.
Last information.
I'm
Are you
terrified.
gonna get emotional?
Am I gonna get emotional? You know what? I feel a tremendous weight.
You don't have to like encourage.
And really, I probably won't get emotional until July when the AP scores come in.
We all fail.
And I see that everybody, and I get 100% pass rate, I might shed a tear or two.
1 tear.
You never say you shed that tear.
If we all pass,
Then we'll
we
go
have
bowling.
Yeah, can we have a party?
We go ice skating.
No, then we can have new Delano's.
Yeah. That's an 85.
I can't ice skate. We can teach you. I can't ice skate. I can roller skate.
You will.
Yeah, I'm like,
Write this question down, please.
these are like the 3-year-olds.
That's the last
You'll
one.
be great.
Just hold on to like the
Hey,
wall.
if we have a 100% pass rate, I will take everybody ice skate.
Yes.
Y'all better pass, dog.
I know. I love ice skating. Well, ice skating anyways. We'll just have to try.
How do signals move from one neuron to another? That's one question and one concept.
That was not a context.
Isn't that what we just answered?
No, we talked about how they move down an axon and then that it'll go to the next neuron, but we didn't talk about actually how it moves. Yes, yeah.
Zoom in a little bit.
And then the last question that we'll deal with.
Yes.
Wait, I think that's why we're confused, because neutral is
I think you went over this one.
Yes,
Yeah.
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 Oh, you left this.
Okay.
It's okay.
So I left a space. We're going to fill this space in with our last two concepts. So how do signals move from one neuron to another? Now we said that the electrical signal is a chain reaction down the axon. And then I said, and then it just goes to the next one, but we didn't say how. Neurons release chemicals into the space between neurons. This space is called the synapse. Okay? So neurons release chemicals into the space between neurons called the synapse. The next neuron responds, and you're going to like this, chemically. To the chemical. So what this means is even electrical signaling requires chemical communication.
That's crazy, dude.
You see that? Do you see it? Do you feel it? Do you hear it? Do you taste it? Am I missing one? Did I get them
Do
all?
you touch it?
Can you feel it? I said feel it. Feel it, hear it, taste it.
See
Smell
it,
it.
see it, see it. So you think it.
Man, I felt a little bit like Daft Punk there. No, it was just like the that song's got like a whole bunch of like feel it, twist it, turn it. This feels like a French pop.
Dang it! Sorry.
Twist it.
I thought of it.
Smack it.
Yes, I did.
I said it.
Pull it.
Faster.
Okay.
Okay.
I did copy.
Are you really fighting over who said bop it first? I said bop it first.
No,
You
I'm not
did it.
denying that you said it first. I'm saying I didn't copy
Listen,
it, saying I thought of it.
Listen. Rick has a reputation of taking credit from other people on himself. So if you are ever concerned that somebody's going to, whether or not they're going to believe that you came up with it and not Rick, we're always going to believe it was
No,
you.
that's fine. I admit to what
Okay.
it was.
Shh. All right. So that is our second to last concept.
Not maybe before you. I didn't hear you.
Get over to be arguing while we're using.
My computer went to sleep. This is the second to last concept. Shh. So when the electrical signal gets to the end of a neuron, it triggers that neuron to release a chemical into the synapse that the next neuron responds to chemically by carrying on an electrical signal. Okay? Okay, what other ways can we divide the nervous system? We can divide it into the autonomic, which this is automatic,
I love this when
when Carrie laughs at you, that's how you do this stuff.
You don't. So the autonomic division of the nervous system, you don't actually have to think about this. Oh gosh.
Finish it.
No, we're gonna have to finish this on.
Finish it.
Come on, don't
Let's get it over with.
Just like,
Do it.
I can't think of that last word.
No, don't worry.
Oh,
Like, just think.
You got it.
Oh my gosh, I totally blanked on it. No, I got so nervous.
It's the last thing ever!
Autosomal.
No.
Don't read it! You're gonna not make it.
What's happening?
Check your laptop. Reaction.
No, I can't do it. I gotta think of it.
You're thinking.
Don't fight everything.
What other ways to divide the nervous system?
Wow. I really can't think of it.
Oh my god.
Here.
So sad.
I know I have to check it. I gotta get you this last piece of information.
Are you excited for
this is like,
Let's learn about apbio. We just loved it so much.
Oh.
I think we have to put it back.
The last one.
Okay.
Somatic.
Are you blind? I'm not.
Yes.
The autonomic, the automatic, and the somatic nervous system. It's under.
And that's biology.
That's it.
Pungent.
No, we can't end it on that note.